Hello Matrix and welcome to MV Tutors. I'm Solo and I'll be looking at the May, / June Maths Paper 1 memo with you guys. Alright, so without wasting any time, let's get straight to it. And while we're getting there, please do not forget to like our videos and also subscribe to our channel. Alright, so question 1. Solve for x. Now, this is where you must shine and make sure that you get all the marks. Okay, so we have 3x squared plus 5x is equal to 0. Now here I can take out the common factor, which is x. So I'm left with 3x plus 5. And that's equal to 0. So x is equal to 0, or 3x plus 5 is equal to 0, then we can see that x will be equal to minus 5 over 3. Okay, that was fair enough. 1.1.2. As soon as you see answers correct to 2 decimal places, you know you must use your quadratic formula. So we have 4x squared plus 3x minus 5. So don't try factorize and just go straight to the quadratic formula. Alright, and if you forgot, this is what it is. Ooh, okay. Alright, so what is b? In this case, b is 3. And then we have 3 squared minus 4 times 4 times minus 5. All under the square root. And then 2 times 4. This is where we employ the calculator now and aim to get our answer. So put it as it is in the calculator. Okay, so we have 3 squared minus 4 times negative 5. You can put brackets if you want to. Okay. Alright, the calculator is still thinking. My goodness. So we have x is equal to 0.80, or x is equal to negative 1.55. Okay, they said to 2 decimal places, so that's where we're going to leave it. Now let's look at 1.1.3, which is the inequality. Alright, so we have x minus 1 squared minus 9. So this is a quadratic function with a turning point of 1 and minus 9. But we are solving for x here, so what I would suggest is let us first multiply out and remove the brackets. So we have x squared minus 2x plus 1 minus 9. It's bigger and equal to 0. And if we simplify it, we get minus 8, right? Now we can go and determine the values of x as we factorize. So with 8, I can have 2 times 4. And if I say minus 4 plus 2, I will get minus 2. Okay, so if I were to sketch then this parabola, it's a happy face parabola, by the way, I know that firstly x will be equal to negative 2, and then we have x is equal to 4, right? So there we have our negative 2 and our positive 4. Now which portion are we going to highlight or shade? We have here that it's bigger or equal to 0. So if it's bigger, it means we're looking above the x-axis, okay? Because this just symbolizes that, your y is bigger and equal to 0. Okay, this entire thing is your function, all right? So that's why we look above the x-axis. If it was smaller or equal to 0, we would have looked below the x-axis. And as such, our answer then will become, because x here is smaller and equal. We indicate the equal part with a solid dot. So x is smaller and equal to -2, or x is bigger and equal to 4. All right, moving right along, we have 5 to the power 2x minus 5 to the power x is equal to 0. So in this case, think about if you had 2x squared minus x is 0. Okay, the temptation is to take the 5 to the power x to the other side. All right, you have the same base, you make the powers equal to each other, and you realize, yeah, you start realizing, okay, cool, 2x, if I divide by x both sides, I will have 2 is equal to 1. Okay, that cannot be. All right, so the issue with taking the 5x to the other, or 5 to the power x to the other side, you are depriving yourself of other solutions. Okay, for example, here, if I say that's equal to x, I can just divide by x both sides. This one is a bit better. Okay, so then you only have one solution, but the best way to do it is what we did for 1.1.1. Instead of taking 5x to the other side, we just factorize. Okay, so let's use the same approach even here. Sorry about that. Okay, so the common factor here would be 5 to the power x. And what are you left with? You are left with 5 to the power x minus 1. And that's equal to 0. So now we have 5 to the power x, which is equal to 0. Or 5 to the power x minus 1 is equal to 0. Now 5 to the power x is an exponent. Okay, an exponent looking something like that, where it passes through 1. Is there ever a point where this graph will actually equal 0? It won't, all right, because our asymptote here is y is equal to 0. Okay, so 5 to the power x can never be equal to 0, all right? And then what do we do on the other side? Well, we say 5 to the power x is equal to 1. Is there ever a point where 5 to the power x is equal to 1? Yes. If we drew it here, that's when x is equal to 0. But anyway, let's just solve it. So here, since your unknown is an exponent, you can use logs, all right? You could say x is equal to log 1 base 5, and you actually figure out that it's actually 0, but let's check on the calculator. So basically we have log 1 base 5, so base 5 log 1, it's 0. Or instead of using logs, you could have said we have 5 to the power x. 1 is the same as saying 5 to the power 0, so that is straightforward. X is equal to 0. Okay, so those are your answers. And now 1.1.5, now we have x all over the square root of 20 minus x. Whenever I see a square root, when we have to solve for x, I know I need to check my answer afterwards. Very important. Something that we sometimes forget. Okay, now if I take the root 20 minus x to the other side, I'll just multiply that by 1. And then I square both sides because I want to get rid of the square root. So I have x squared and then 20 minus x. I'm going to take everything back to the left-hand side. Okay, so x squared plus x minus 20 is 0. And then if I factorize it, the factors of 20, if I use 5 and 4, I know positive 5 minus 4 will give me positive 1, and positive 5 times negative 4 will give me negative 20. Okay, so then here I know that x is equal to minus 5, or x is equal to 4. Now, this is where the check comes in. Is x really equal to minus 5 and 4. So let's first start. We go to the original equation that was given. If I put minus 5, okay, minus 5 over root 20 minus 5, okay, is that equal to, no, it's not equal to 1, it's equal to negative 1, so x is not equal to minus 5. What about 4? If I put positive 4, and then there we have 20 minus 4, we get 1. So x is equal to 4, but x is not equal to negative 5. And now let us solve simultaneously. Okay, so we are cruising through question 1. So we have x plus y is equal to 9. And we have our complicated equation, 2x squared minus y squared is equal to 7. So I'm going to write x in terms of 9. In terms of y. Okay, so that is equation number 1. And this is equation number 2. So I will then substitute equation 1 into equation number 2. So in the place of x, I will put 9 minus y squared is equal to 7. Okay, now if I get rid of the brackets, 9 squared is 81. 9y plus 9y is 18y. And then we have y squared minus y squared. I'm going to bring the 7 to the left-hand side. Now 2 times 81, that's 162, right? 18 times 2, that is 36. And then we have 2y squared minus y squared minus 7 is 0. So I'm just going to, highlight the like terms. So 2 minus 1, I have y squared remaining. And then 36y is there by itself. And then I have 162 minus 7. So in this case, I'm going to use the calculator. I can work it out, but, let's just be certain. So it's positive 155. And that's equal to 0. The factors of 155. So at this point, I would suggest you use the quadratic formula, unless if you want to figure out the factors of 155. So I'm going to take a guess and see if I can say 155 divided by 35, if I won't get anything. No. Okay, if I say divide by 31, why am I using 31? Because I'm looking at this 36. Or actually, if I say 155 divided by 5, because I want to see if I can use 31 and 36. Okay. So I have 31 and I have 5. Okay. Let's put the y's. So which one goes away? So minus 31 minus 5 will give me minus 36. Okay, so here we go. And then now my answers, y is equal to 31 or y is equal to 5. So that's just the first part. Let's now get x, right? So we're going to substitute our y values into equation number 1. Remember equation number 1, x is equal to 9 minus y. So x is equal to 9 minus y, where y is 31. And x is equal to 9 minus y again, where y is equal to 5. What is 9 minus 31? It's negative 22. So x is negative 22, for y is equal to 31. And x is equal to 4, for y being equal to 5. At this point, you can check, right? If I say x plus y, so my y here is 31. Okay, let's start with the x. So if I say x, negative 22 plus y, I get 9, right? Which is true. And if I say 4 plus 5, obviously that's 9. So yeah, the answers actually do work. So I can confidently move on and finalize question 1. So now 1.3 given, we have that p is equal to 1 minus a, and t is quite long. So we have 1 plus a, 1 plus a squared, 1 plus a to the power 4, all the way to 1 plus a to the power 5, 1, 2. Okay, if I look carefully at this, this side, that is, I mean, we have a to the power 1 basically. Okay, so these they look like we need 2. Okay, let me just put it. So 2 to the power 0 would give me 1. 2 to the power 1 is 2. Okay, so there's the 1, there's the 2. Then 2 to the power 2 is 4. 2 to the power 5 would give me 30. No, 2 to the... Jeez, I'm skipping 3 now. So we have 8. 2 to the power 4 is 16. To the power 5 is 32. 2 to the power 6, 64. 2 to the power 7, what is that, 128. 2 to the power 8, let's double that, 128 times 2, 256. 2 to the power 9, we get 512. Okay, so we can see, quite a lot here. But anyway, this is just what, I'll be thinking in my head. I will definitely not be writing this down in my question paper or answer sheet. Yeah. But anyway, it says determine the value of p times t in terms of a. So what will that look like? So we have 1 minus a times t, which is 1 plus a, times 1 plus a squared, and we go all the way to 1 plus a to the power 5, 1, 2. So what happens if I multiply these two? I see I have a difference of 2 squares, so my answer will be 1 minus a squared. And then I multiply it by 1 plus a to the power 2 times all of that. So now, again, I have a difference of 2 squares, so 1 minus a to the power 4. And what's next? 1 plus a to the power 4. Do you guys see a trend here? Am I the only one? I'm seeing a trend. Okay, so we're going to do all of this until we get to a point where we have 1 minus a to the power 5, 1, 2. And we're multiplying it with the last term that we have there, which is 1 plus a to the power 5, 1, 2. And then our final answer, again, difference of 2 squares, we're going to say 1 minus 5, 1, 2 plus 5, 1, 2. Okay, remember when we multiply the same base, we add the exponents. So we're going to get 1024. And that is your answer for p times t. Okay, and that is it for question 1. Alright, now let us look at question 2. So 2.1 says consider the geometric series. Okay, remember there's a difference between a series and a sequence. So if it's a series, then you are adding up the terms. If it's a sequence, you're just listing the terms. So if we go from term 1 to term 2, you can see that we actually multiplied by a half and so forth. Okay, so already you can see that r is a half. But anyway, let's see. 2.1.1 says, does this series converge? Justify your answer. So yes, it does converge. Why? Because r is in between -1 and 1, right? Remember, r is a half. Okay, so as soon as you have a number in between -1 and 1, then you know that your series will converge. 2.1.2 says calculate the sum to infinity. Alright, the sum to infinity is a over 1 minus r. The first term is 4 and the ratio is a half. So 4 divided by a half will give you 8. And then 2.2. Now we have sigma notation. For some of you, it is a thorn in your flesh. But it's actually not that bad. Alright. You just need to identify whether you have an arithmetic series or a geometric. And you know, if your unknown is in the exponent, then you have geometric. If your unknown is just in a normal place, then you have an arithmetic series. Okay, so they tell you the sum from k up until 10 for this series. If you add up all those terms, you're going to get 29,520. Okay. Now it says calculate the value of k. So what do you do normally when you have sigma notation? I would suggest, first of all, get the first term, the second term, and the third term. And by finding those terms, you eventually get your common ratio. Alright, remember the first term is equal to a. So how do we get the first term? Firstly, you're going to substitute whatever is here in the place of p. So we're going to have 3 to the power k minus 1. And then the following terms, you just add 1 to it. So it will be 3 k plus 1 minus 1. And then 3 to the power k plus 2, because you keep adding 1 more. Alright, if we simplify this, we're going to get 3 to the power k. And for the third term, you're going to get 3 to the power k plus 1. Now, how do we get r? We take the second term and divide it by the first term. And it should be equal to the third term divided by the second term. Okay, but firstly, let's have a look at the second term divided by the first term. So we have 3 to the power k. The first term is 3 to the power k minus 1. Remember, if you have the same base and you are dividing the numbers, you can just subtract the powers. So k minus 1. So that's 3 to the power k minus k plus 1. So basically, r is 3. And if you wanted to just make sure, you can take the third term and divide it by the second term. So the third term is 3 to the power k plus 1 divided by the second term, which is just 3 to the power k. So we're going to say k plus 1 minus k. And you can see at the end you're left with 3 to the power 1. So r is 3. That's your common ratio. A, the first term, is 3 to the power k minus 1. What is n? How do you get the number of terms? Please do not assume that you just put 10 and that's it. It doesn't work like that. So you take the number at the top and the number at the bottom and add 1. So 10 minus k plus 1. So basically n is equal to 11 minus k. Now it says calculate the value of k. I'm going to use the sum formula because we are summing these terms, aren't we? So the sum formula is for a geometric series, r to the power n minus 1 over r minus 1. Let me just check. That's why the formula sheet is there. Oh no. Okay. I don't have the formula sheet with me. Okay, so I'm kind of playing a dangerous game here. But I think this is the formula. Okay, I think I've been doing this for quite a while now. So yeah, I will go with that. So A, we have 3 to the power k minus 1. Okay. And then R is 3. N is 11 minus k. And then we're dividing by 3 minus 1. And the sum, they gave it to us, it's 29,520. Alright, so 3 minus 1, that's 2. So I'm going to say 2 times 29,520. And that gives me 59,040. So we've dialed, we don't have a fraction anymore. We're comfortable. Now, we need to multiply this inside. Okay, so I have 3 to the power k minus 1 times 3 to the power 11 minus k. Remember, when we multiply and we have the same base, we're going to add the powers. So I have k minus 1 plus 11 minus k. And then there's a subtraction sign, and I have 3 to the power k minus 1. Let's see where this leads us. So we have 3. Now k minus k, so that's fine. And then minus 1 plus 11, that's 10. And then minus 3 to the power k minus 1. And then we have 59,040. So I'm going to take 3 to the power 10 to the other side. Then I'm left with negative 3k minus 1. Okay, so now let's use the calculator. We have 59,040 minus 3 to the power 10. Okay, so we have negative 9 is equal to negative 3. I'm glad we have a 9 because 3 squared is 9. So I'm just going to multiply by negative both sides to get rid of that negative. I have 3 to the power 2 and 3 to the power k minus 1. So I can say 2 is equal to k minus 1. Therefore, k is equal to 3. Okay. Is that it for question 2? Yes, it is. Question 3. We're still at the sequences and series, and now we have a quadratic pattern. All right. We have 3, 7, 12. Okay. And it says in 3.1.1, show that the general term of this number pattern is given by that formula. All right, so let's go ahead and get the first difference. All right, so we're going to get 4 here and 5. Then we have 1. Normally in a quadratic pattern, they give you 4 terms, but I guess they've told us that it's a quadratic pattern, so we can just determine that. All right, now we can say that 2a is equal to 1. Therefore, a is a half. Then we go to 3a plus b is equal to 4. So 3 times a half plus b is 4. Therefore, b is 4 minus 1.5. Because 3 times a half is 1.5. So b is 2.5. We can write that as 5 over 2. And then c, okay, let's put it like this, a plus b plus c, that will be equal to 3. So a is a half, b is 2.5, so a half and 2.5 is 3, and 3 minus 3 is 0. So therefore, our term formula for this quadratic pattern will be a half n squared plus 5 over 2n plus 0. And we're not going to include that, and we have shown it. All right, 3.1.2. What number must be added to Tn minus 1 so that Tn is 13,527? So you know how we normally say we have Tn and then the next term will be Tn plus 1? Well, now we have Tn minus 1. Okay, and they want to know what this value is that needs to be added to Tn minus 1 in order to get Tn. And they've given us Tn, right? So Tn, which is equal to a half n squared plus 5 or 2.5 n, is actually equal to 13,527. So we have a quadratic pattern. Okay, at this point, I'm just going to multiply everything by a half, by 2, basically. I don't like fractions. So I'm going to have n squared plus 5n And then what is 13,527 times 2? It is 20. I'm going to bring it to the left hand side. So minus 27,054. Okay, and at this point, I'm going to employ the quadratic formula. So I have n is equal to minus b, which is 5 in this case, plus minus, and then b squared minus 4ac, 27,054. Don't forget that square root, and divided by 2a, which is just 2. So let's put that all in a calculator. We have minus 5 plus square root of 5 squared, which is 25, 4 times negative 27 and 54 divided by 2, and we get that n is 162, or n, I am assuming it's going to be a negative answer. I've never had a case or scenario where I have two positive answers. If that were the case, then I would be screwed. Because like, which one do you choose? But n cannot be a negative answer, right? So n is actually equal to 162. So basically, T162 is equal to 13,527. But we're looking for Tn minus 1. So T161. What would T161 be? So let's go to our formula. A half n squared plus 2.5 n. Alright, so we get 13,363. And what is the term? Because what we're looking for is for me to get to 160, to get from 162, from 161, term 161 to term 162, what do I need to add? Okay, so I'm going to say 13,527 minus the answer. So I need to add 164. That is my answer. Okay, so let's just look at the question again. What number must be added? This value over here must be 164. Okay, or you can write down the value to be added is 164. Okay, so that sums it up for 3.1. Now we can go to 3.2. It says, given an arithmetic sequence with term 1 equal to 8 and term 2 equal to 11. Calculate the value of n if Tn is 41. All right, so I'm going to go ahead and say term 1 is a plus n minus 1d. So I know term 1 is 8. Okay, actually, yeah, I think let's not even do this formula because I'm just going to say a is 8 because that's the first term. And then term 2, which is 11, okay, a plus n minus 1d. So term 2 is 11. The first term is 8. N, that's 2. And now we're looking for d. All right. So if I take 8 to the other side, 11 minus 8 is 3. And 2 minus 1 is 1 times d, that's d. So d is basically equal to 3. Now if I'm looking for Tn equal to 41, so that's a plus n minus 1 times d, that's equal to 41. My term is 8, first term. I'm looking for n, and I know that d is 3. So I'm just going to multiply out 3n minus 3 plus 8. So then I'll say 3n is equal to 41. Minus 3 plus 8 is 5. 5 taking it to the side of 41 is going to be minus 5. So 3n, what is 41 minus 5? That is 36. Okay, so n, if I divide by 3 both sides, n will be equal to 12. And then we can go to 3.2.2. A new arithmetic sequence P is formed using the term position and the term value for the given arithmetic sequence. Now for this new sequence, P8 is equal to 1. P11 is 2. And so forth. So now A, they ask us to write down the value of P41. And it's only 1 mark. I'm thinking I have a lot of work to do. So if it's 1 mark, I need to somehow relate it to what was there previously. Remember previously, we had that T1 was 8, T2 was 11, and that T12 was 41. So they're basically swapping places. Do you see? So now, what am I expecting there? I'm expecting P41 to be 12. Okay, so let me just write it out nicely. P41 is 12. And for B, now it says calculate the first term of the new arithmetic sequence. Okay, so P41 will be equal to A plus N minus 1D. Now I know P41 is 12 and N is 41. So 41 minus 1, that's 40. So I have one equation. I need to get another one. Okay, and I can use P8 is equal to 1. For argument's sake, I could have used P11 is equal to 2, doesn't matter. So P8 is equal to 1. So I have A plus N minus 1 D. So P8 is 1. And then I have A. N is 8 minus 1 is 7. So I have 7D. So I have my second equation. And then what I can do, I can basically say equation 1 minus equation 2. So I have 12 is equal to A plus 40D. And I have 1 is equal to A plus 7D. Equation 1 minus equation 2. 12 minus 1 is 11. A minus A is 0. 40 minus 7 is 33. So D is 11 over 33, which is simply 1 over 3 if I simplify. So I have D, I can substitute it back in any equation. Okay, so we're going to substitute D in equation, anyone will do. Equation number 2, smaller numbers that I'll be dealing with. Okay, so 1 is equal to A plus 7D. I'm going to write this all in terms of A. So A is 1 minus 7D, and I have the value of D as 1 over 3. So since I have a fraction here of 7 over 3, I'm just going to convert this 1 to 3 over 3. Okay, so 3 minus 7 is negative 4. So that is the value of A, 4, negative 4 over 3. Okay, and we are done with question 3. These questions are going rather quick, and so far so good. So question 4, we have the function g of x. Don't forget to like our videos and also subscribe to our channel. Thank you for those who have been subscribing and liking. All right, so we have a hyperbola, okay? And we can see it has been shifted 1 unit to the right and 2 units up from the origin. Now, 4.1 says, write on the equations of the asymptotes of g. So basically, how has it been shifted horizontally? it has been shifted 1 unit to the right, so x is equal to 1. And how has it been shifted vertically? It has been shifted 2 units up, so y is equal to 2. Then 4.2, draw a graph of G indicating any intercepts with the axis and asymptotes. At this point, I would calculate the intercepts, okay? So let's go ahead and get the y-intercept, where x is equal to 0. So then I would have y is equal to 1 over negative 1 plus 2. So negative 1 plus 2, that's just 1. So we have the value of y. Okay, so we know this is one of the coordinates. Now what about the x-intercept? That is basically where y is equal to 0. So I have 0 is equal to 1 over x minus 1 plus 2. Then I'm going to take 2 to the other side. And, oh, what am I adding? And then I'm going to take x minus 1 to the other side. I'm left with 1. So negative 2x plus 2 is equal to 1. Negative 2x is equal to, if I take 2 that side, negative 1. So x is a half, positive a half. So then I have another coordinate, half and 0. So when I sketch this, okay, let's sketch away. This is my y-axis and my x-axis. All right. I know that the equation of my asymptote, I have x is equal to 1. So I'm going to have 1 over there. I'm going to draw in my asymptote because that is where the graph shouldn't actually touch. And I had y is equal to 2. So again, the graph shouldn't touch there. All right, and then I calculated my intercepts. I know that x is equal to a half. So that's a half, and I know that y is equal to 1. Okay, so basically it's halfway our asymptotes. Okay, now I can sketch the graph. So I know one side of the graph is going to look like this. Okay, let's just say 1 is there. Ooh, what happened now? No. Oh, how did I even get to the internet? Okay. There's 1. Okay, so that's the first half of my asymptote, and then the other half will be here. All right. I don't like how this sketches it, so let me just sketch it my way. All right, so that is basically our asymptote, our graph sketched with the asymptotes and the intercepts. All right, and that is your 4 marks that you'll be getting. Now 4.3 says determine the values of x where our function g of x is bigger than 0. If it's bigger than 0, it means we are looking at this place above the y-axis. Sorry, above the x-axis, where basically y is positive. So we are focusing on values above the x-axis. So I can see where g is bigger than 0. It's in this region over here. Okay, until we get to x is equal to 0. Okay, but then we even go all the way to where x is equal to a half. So that's where it's big. And then here, it's basically everywhere. it will go on and on and on. So how do we write down that answer? Okay, so we went from negative infinity all the way to a half, positive a half. Let's just change back. So basically, where x is smaller than a half, or you could say x is an element of negative infinity all the way to a half. Okay, and it said where it's bigger than 0, not bigger and equal to. So you're going to have round brackets if you write it in this way. Okay, and also where x is bigger than 1. Okay, remember we have 1 over here. So where x is bigger than 1, that is where you'll also have solutions. Or you could have said we're joining now where x is bigger than 1. So from 1 all the way to positive infinity. And it doesn't touch 1. Please don't put a square bracket around 1. It has to be a round bracket. And that will be your 2 marks. Now 4.4, determine the equation of the axis of symmetry of G which has a negative gradient. Now you know when it comes to hyperbolas or hyperbolas, you have 2 functions, okay? 2 axes of symmetry equations. All right, one which has a negative gradient and another which has a positive gradient. Okay, and what do we know about these? Basically, we know that with the negative gradient, m is negative 1, and then with a positive gradient, m is 1. And in order for us to get an equation of a line, we need a gradient and a point. Now we already have a point, okay, because of our asymptotes, though. The x value is 1, the y value is 2. So we are well on our way to actually get the equation of the negative gradient. Okay, like I said, the gradient is either 1 or negative 1, and our point is 1 and 2. So now we can get the equation of the line. Y is equal to mx plus c. In the place of y, I will put 2. In the place of m, negative 1. In the place of x, 1 plus c. So c is equal to 2. If I have minus 1, when it goes to the other side, it will be plus 1. So therefore, c is equal to 3. And now my equation y is equal to negative x plus 3. It's that simple. And we are done with question 4. Question 5. In the diagram, the graphs of f of x, okay, we can see that's the log function, and g are drawn. Okay, I hope that you see that g is actually the inverse of f just by looking at it. But let's read on. So the graphs of f and g are drawn. Graph g is a reflection of f in the line y is equal to x. As soon as you get a reflection about the line y is equal to x, then you know you are dealing with a graph and its inverse. Okay, graph f passes through the point P, which is 4, 2. Q is the x-intercept of f, and R is the y-intercept of G. So Q and R basically. R is most likely going to be 1, 0, and 1, okay? And Q will be 1 and 0 because they're inverses. Okay, anyway, 5.1 says, write down the coordinates of P prime, the image of P on G. Okay, so if P is 4 and 2, what will P prime be? We're just going to swap because that's the inverse. So it's going to be 2 and 4. Show that A is equal to 2. Okay, so in this case, if you're going to show that A is equal to 2, remember our function f of x is equal to log base A to the power x. Okay, now that's the function of f, all right? If we get the function of g, Okay, that's basically going to be a to the power x. All right. Yeah, but anyway, so what we can do then in that regard, because p prime will be on g, okay, so now we can substitute p prime. Okay, so in the place of y we have 4, in the place of x we have 2. Okay, and if I'm then looking for a, by the way, with g, do you see that this is a positive function? Okay, because in this case you could say a is equal to plus minus 2 but the function of g is actually has a positive a value, so we're not going to consider the negative portion of the formula or the answers. We're going to only look at the positives. In this case, a would be equal to 2. Okay, therefore I can write down the function. You could have really taken the function of f of x and substituted 4 and 2 and then gotten a. Yeah, there's more than one way of getting the answer. So f of x then becomes log base 2x, and g of x becomes 2 to the power x. This is just something to put for yourself. Oh, okay, so I went ahead. 5.3 says write down the equation of g in the form y. Okay, so y is equal to 2 to the power x. That's 1 mark as expected. And then 5.4, t is a point on f. Okay, let me see if I can write here. So t is a point on f. Okay, and what else has been written? T is a point on f in the first quadrant. So we are here, first quadrant, where TR is parallel to the x-axis. So if I have R there, T must be somewhere here because it is parallel to the x-axis. Okay, so yeah, we have T, we have R. Now calculate the area of triangle R, T, and P prime. Remember P prime, we got it to be 2 and 4. And remember when I said here R will actually have the coordinates of 0, 1, meaning Q is 1 and 0. So probably here, that's where you get 2, right? If at Q that's 1, this is most probably 2. And if we take that line upwards, okay, we get P prime. So P prime is probably somewhere there, which is 2 and 4. Okay, but we need to just make sure what are the coordinates of T. So yeah, if we know that the y coordinate, so for T we don't know the x coordinate, we are hoping it's 2, because if it's not 2 then our calculation will be quite complicated. So we're looking for the x value. We know, however, that the y value is 1. And remember, we already have the function of f of x. So let us go ahead and substitute the y value, which is 1 log base 2 x. Okay, so now let's solve for x. So basically I can rewrite this as log x over log 2 is equal to 1. If I take it to the other side, log 2 is equal to log x. I can get rid of the logs, so basically x is equal to 2, which is great news. So it means t is 2 and 1. Okay, you write it there. T has the x value of 2 and the y value of 1. So now I want to know the area of triangle R, T, and P prime. So I hope you see that we actually have a right angle triangle. Okay. Okay, we have a right angle triangle. So that makes life very easy for us. Let's just redraw it over here. Okay, so we have T, P prime, and R. And the distance between R and T, we're going to look at the x values. So we have an x value of 0 and an x value of 2. So the distance is 2. And the distance between P prime and T, y value is 1. P prime, y value is 4. So that would be 3 units. So therefore, the area of triangle RT P prime is half base, which is half RT, times height, which is P prime times T. Okay, so we know that RT is 2 units, P prime times T is 3 units. So 2 times 3 is 6, times a half, 3. So we have 3 squared units, or 3 units squared, and that is the area. Okay, and that is it then for question 5. Question 6, we have a parabola and a straight line. So the graphs of f of x and g of x are drawn below. D and E are the x-intercepts, and P is the y-intercept of function f. The turning point of f is T, 1 and negative 4. They were very gracious to actually tell us. We could have calculated it because we have the formula for f. The graphs of f and g intersect at P and E. Alright, so now 6.1, write down the range of f. Okay, range is all the y values. Okay, so y is an element of, we are starting at negative 4 and it is included. Okay, so negative 4, and where are we ending? Well, infinity, which we don't know. Okay, so you could have written it like this, or you could have said y is bigger and equal to negative 4. Either way, you'll get the mark. Is it a mark or 2 marks? It's just 1 mark. All right. Yeah, and then 6.2 says calculate the coordinates of D and E. So basically we're trying to get the x-intercepts. So if you're going to calculate the x-intercepts, our y has to be 0. So we have 0 is equal to x squared minus 2x minus 3. So we can factorize that quite well. So we'll have 3 and 1. And because we have negative 2, so negative 3 plus 1 will give you negative 2. Okay, therefore x is equal to 3 or x is equal to negative 1. But they wanted the coordinates, not just the x values. So in this case, D will be equal to negative 1 and 0. And E will be equal to 3 and 0. So you can basically write that down. We have 3 and 0, negative 1 and 0. Okay, great. Now 6.3. Determine the equation of G. So that's basically the straight line graph. So what do we need in order to get an equation of a straight line? Either we need a gradient and a point, or we need 2 points. Okay, and I can tell you we have E, right? That's one of the points, and we just calculated it. Another point is P. What would P be? Do you see that P is actually the y-intercept of f, and the y-intercept of f is minus 3 based on this equation. Remember, y-intercept, that is where x is equal to 0. So y would be 0 squared minus 2 times 0 minus 3. So you get ultimately that y is negative 3. So P would be 0 and negative 3. I have 2 points. I can basically use that to get the equation of the graph. And how do I do that? Basically, I can say y is equal to the y coordinate of E, and x is equal to the x minus the x coordinate of E. And then we have the y coordinate of P minus the y coordinate of E. over the x-coordinate of P minus the x-coordinate of E. So what is the y-coordinate of E? It is 0. The x-coordinate of E is 3. The y-coordinate of P is minus 3, minus 0, and then we have 0, minus 3. So here I have y over x minus 3 is equal to minus 3 over minus 3, which is just 1. So basically y is equal to x minus 3, and they wanted the equation of g of x, so I just need to write it in terms of g of x. Okay, there it is. Now 6.4, write down the values of x for which f of x minus g of x is bigger than 0. So if I have f of x minus g of x, it's bigger than 0. Basically, I'm saying where the y values of f minus the y values of g will be bigger than 0. For me, honestly, I would rather take g to the other side and say, where is f of x bigger than g of x? Where are the y values of f bigger than the y values of g? So I see here, straightforward, that the y values of f are big up until we get here at P, okay? And then it's the y values of g that are big until we get to E. And then again, I see the y values of f are bigger after E. Okay, so basically from P, going to the negative infinity, that's where f is big. Okay, so basically P, that is where x is 0. So where x is smaller than 0. Okay, and also, or rather let me just say, or where x is bigger than 3. Okay, or I could have said x is an element of negative infinity to 0, round bracket, please, and then from 3 to positive infinity. Okay, that's how I could have written the answer. And now 6.5, it says determine the maximum vertical distance between h and g. So what is h? They've introduced a new function. H is the negative of f of x. Okay, for x is an element of negative 2 to 3. So basically looking at the x values from negative 2 to 3. They've given us the domain. So if h of x is negative f of x, I will then have negative x squared plus 2x plus 3. Remember, f of x is x squared minus 2x minus 3. So now we're applying a negative to it. So if I were to plot this new graph of h, it would basically look something like this. Okay, and that would be 1 and 4. All right, so that's the new function. So now I want to know the maximum vertical distance between h and g. Remember, g is our straight line. So if I were to look, let me just highlight it, maybe in blue. Okay, the maximum vertical distance. So if I start where they intersect, okay, that's like the minimum. All right, but if I keep going, the maximum looks like it could be like somewhere around here, okay, in this region. That's where the maximum would be. Okay, so that's what I'm expecting. Now, how do I calculate that? If you forgot, as soon as you hear maximum, minimum, you should think calculus. But what if you forgot about calculus? Well, what I would suggest you do, which is a very long way of doing it, but I mean, it's 5 marks. So I would suggest, if you forgot about calculus, put the function of h of x, put the function of g of x, and then get the difference between h and g. And whatever value you get, we're starting way at minus 2, minus 1, 0, 1, 2, and 3. Okay, and as you determine those values, then see where would your maximum be. Okay, so I'm going to pause and populate this table. So after populating it, I see actually the maximum should be around here, should be somewhere in the middle. Okay, so in that case, I would say, okay, between 0 and 1, I have a half. If I put a half inside the equation of h of x, what do I get? I get 3.5. And if I put a half in the equation of g of x, I get negative 2.5. So 3.5 minus 2.5, I'm going to get 6.25. No. Let me see. I don't think I have the right value there. So negative 0.5 squared plus 2 times 0.5 plus 3. Okay, 3.75. Yeah, I knew I was missing something there. Okay, 3.75. Okay, so 3.75 minus 2.5, I get 6.25. So basically, the maximum vertical distance between H and G will be 6.25. That's if you forgot about calculus. Now, if you remembered calculus, you could simply say H of x minus G of x is equal to negative x squared plus 2x plus 3 minus x minus 3. Remember, that's the function g, x minus 3. And then we just simplified. So x squared, now I have 2x minus x, so I'll be left with x. And I have 3 minus 3, which is 6. And then I'm going to get the maximum value. Okay, so hx minus gx, so max, I'm going to get the first derivative. So using the power rule, negative 2x plus x, and we make it equal to negative 2x plus 1, make it equal to 0. So I have negative 2x is equal to negative 1. Therefore, x is a half. All right. And then if x is a half, I need to go substitute that value in this equation. So I have negative a half squared plus a half plus 6. Okay, and we have 6.25, which is quicker and simpler. And you got a half, unlike using a table where you're like having to figure out that there should be a number in the middle. So there we go. I showed you 2 ways of calculating it. Okay, and then 6.6. Now, given that k of x is equal to g of x minus n, determine n if k is a tangent to f. Okay, so basically g of x has been shifted vertically in order for it to be a tangent to f. Okay, the only way I see it being a tangent to f, let me use a red line, is if you shift it downward, and it becomes probably something like that. Okay, if n is, if you shift, actually it was minus n, so it means it is already a downward shift. So the value of n that we're going to get has to be positive. If it was gx plus n, then the n that we're calculating should be negative. Okay, so it is a downward shift, because if I take g of x up, I don't see where else it could be a tangent. It can't be a tangent if I take it up. Okay, so I had to take it down. Now what am I going to do? My k function will then be x minus 3 minus n. Remember, g of x is x minus 3. And it will touch, because it's a tangent, it will touch f. Okay, remember what f is? F is x squared minus 2x minus 3. So if it touches, it means at that point, the graph of x and the graph of k and the graph of f are actually equal to each other at the tangent. Okay, so I have x minus 3 minus n is equal to x squared minus 2x minus 3. And I'm going to take everything to the right. So I have x squared minus 2x minus x minus 3 plus 3 plus n. So if I simplify that, I will have x squared minus 3x. The 3's will cancel and I'll have n. Okay, and wherever I have an unknown in a quadratic formula, I'm going to think about the discriminant. Okay, so if I think about the discriminant, remember, is equal to b squared minus 4ac. Okay, and I'm going to make that equal to 0. Now, what is a? I know that a is 1, b is minus 2, and c is n. So I'm just going to substitute all of that. So b minus, oh gosh, did I just put minus 2 there? b is clearly minus 3. So I'm going to put minus 3 and square it. Minus 4a is 1 and c is n. So I have 9 minus 4n is equal to 0. So 4n is equal to 9. And n will then be equal to 9 over 4. So I needed to shift the graph of g 9 over 4 units down in order for it to be a tangent. Okay, and that's it for question 6. All right, we are at question 7 now. Financial maths. So 7.1. 6 years ago, Tabo bought a phone for 13,000. So we'll just write down the values as we go along. The value of the phone depreciated annually according to the reducing balance method. Okay, so you should know what formula we use for reducing balance method. The value of the phone is now 8,337 Rand and 75 cents. Calculate the annual rate of depreciation. Okay, so basically we're going to use this formula. Instead of a plus, we're going to have a minus because it's depreciating to the power n. Okay, that's the reducing balance method. Now in the place of a, we're going to put 8,337 and 75. In the place of p, we put 13,000. And then we're looking for I. And they said 6 years ago. So in the place of n, we're going to put 6. So our unknown then is I. So let's just write everything in terms of I. Let's make I the subject of the formula. Okay. And then we're going to say root 6. And we're going to subtract 1. And we have negative I. Okay. So let's just put that all into the calculator. So we have root 6 and we have 8,337.75 divided by 13,000, and we're going to subtract 1 and we get, okay, let's just say negative I is equal to negative 0,0714, and then we're going to divide by negative both sides and then multiply it by 100. So it's normally best to put it in percentage. Okay, and that's our answer. That's the annual rate of depreciation. You could have put it as D instead of I. but yeah, I'll just leave it there as I. Okay, so 7.2. Eric and Thandi need to save 80,000 Rand each to go on a holiday at the end of December 2027. Thandi decides that, okay, I'm just going to put Thandi this side and Eric on the other side so that we can write the information as we go along. Thandi decides that she will start saving at the end of January 2025. She will make 36 monthly deposits. Okay, so already I know that N is 36. Into a savings account that pays an interest at 8.6% per annum compounded monthly. The deposit will be made at the end of each month. All right. Now, Eric calculates that if he makes 48 deposits, okay, so he will take a bit longer, of 1,000, okay, so we have the monthly deposits, of 1,402 Rand and 31 cents, starting at the end of January 2024, he will have enough money to go on holiday. He will make his deposits into a savings account at the end of each month. The savings account pays interest also at 8.6% per annum compounded monthly. All right. Now calculate the difference between the total amount that Eric and Thandi will deposit into their respective savings accounts over the given period. Okay, so in the case of Eric, we can see that he will deposit 1,402 and 31 Rand. Okay, or 31 cents. Yeah. So, and that will be for 48 months. So now we need to determine then what the total amount that he would have paid over that period is. But before I even get there, I just want to determine if Eric, having put all these monthly amounts, will he have saved 80,000 Rand? Let's check, because in this case, because the money that they are expecting is going to come in the future as a lump sum, we're going to use the future value formula. All right, so let me just separate the two there. And then we'll calculate how much money Eric actually paid over 48 months and how much did Thandi pay over 36 months. Okay, so the future value, monthly amount, 1 plus interest to the power n minus 1, and that is all divided by I. So the monthly payments, 1,402 and 31 cents. Then we have 1 plus the interest, which is 8.6% compounded monthly. Our n is 48. Okay. And we're dividing it by the interest, 8.6% divided by 12. So we're just going to put it here in the calculator and then see if he ended up being able to save 80,000 Rand. So that is the monthly amount. Then we have 1 plus 8.6%. Where is the percentage sign? Shift percent divided by 12. And we're subtracting 1. And we close the brackets. Then we have 8.6% divided by 12. What did I do here? So we have that multiplied 1 plus, to the power, to the power 48. Okay, so yeah, we can see, if we round it up to 2 decimal places, Eric did eventually save 80,000 Rands. So that's great, né? But what I want to know is how much did he actually contribute because we need to see what the difference is between what Tandy contributed and what Eric contributed. So how much did Eric actually contribute? So he contributed, if I take the 1,402 Rand and 31 cents and multiply that by 48, I get, he actually contributed over 48 months 67,310 Rand and 88 cents. Okay, now let's go over to Tandy. So I just need to know how much Tandy contributed per month. So again, using our future value formula, 1 plus I to the power n minus 1 divided by the interest. So it's going to be 80,000 divided by x, 1 plus the interest, and we have 36 payments divided by the interest. Okay, now we need x. We're going to have to rewrite this formula in terms of x. So we're going to have 80,000 multiplied by the interest rate, and we are going to divide by that term, okay, to the power 36 minus 1. All right, so let us go and work out what the monthly payments are for Tandy. So we have 80,000 multiplied by 8.6%. We are expecting a higher monthly amount because she's doing it over a short period as opposed to a longer one like Eric. Okay, she is saving this amount over 36 months. Okay, so whatever you calculate, make sure that that monthly payment, whatever you get, it should be more than what Eric is contributing. Oh gosh. Okay, let's put that again. 1 plus 8.6% divided by 12, and we are subtracting 1. Okay, so her monthly payment is 1,955 and 78 cents. So it is more than what Eric is contributing as expected. But what is the money that she paid overall in that 36 months? So I have 1,955,78 multiplied by 36. And so she paid more overall. So 70,408 Rand and 2 cents. Okay, so the question was, calculate the difference between the total amount that Eric, okay, so I should actually say total amount. So calculate the difference between the total amount that Eric and Tandy will deposit into their respective savings account over the given period. So now let's get the difference. Okay, so difference in the total amount. We have 70,408 Rand and 2 cents minus 67,310 Rand and 88 cents. So if we take that amount, okay, so 70,408,02 minus 67. I don't like using rounded off values, but for the purpose of this exercise, I think I'll be fine. So we have 3,097 Rand and 14 cents. So yeah, that is 7.2. And how many marks was this? 4. Okay, I guess it wasn't really necessary to calculate this. We could have just went ahead and calculated the total amount that Eric paid, but I just wanted to see for myself, like, will he actually make it to 80,000? And he did. Okay, now the last question from question 7.3. It says Lesibana was granted a loan of 225,000 Rand. So already I know that's the present value right there, 225,000. The rate of interest for the loan is 9% per annum compounded monthly. Lesibana will make monthly payments. Okay, so they give it to us, monthly payments of 5,500 starting exactly 4 months after the loan was granted. Okay, so there's a period in which he is not making any contribution towards the loan. All right, guys, at this point, you must know that the money is not just sitting in the bank account doing nothing. It is accumulating interest. Money is always working. Okay, so after 4 months, his present value will not be 225,000 Rand anymore. It will be more. All right, and we have to determine that. Now it says, how many payments will Lesibana make to settle the loan? Okay, so we need to take this amount here and we need to get a new present value. And in order to do that, because we're dealing with a lump sum, we're going to use our compounding formula. Okay, what is our principal amount? It's that 225,000. 1 plus the interest. Now, what is this N? They said he only started making payments 4 months after the loan was granted. So I'm going to put N is equal to 4. Well, remember, whenever you use the present value formula or the future value formula, you don't start making your payments or repayments immediately. You make them after a month. Okay, you're given that 1 month off. It's sort of like a grace period. Okay, so you're not going to pay the first month. You're going to pay at the end of the first month, and then you continue making payments. All right, so actually you won't get 4. N is equal to 4. It will be like 4 minus that 1 grace period. So now we can go ahead and determine how much that 225,000 will be after actually an effective period of 3 months. Okay, so we have 9% over 12, and that is to the power 3. All right, so we see that that amount has been raised to 230,100. So like I said, money doesn't just sit, okay? There's motion, there's movement. Okay, all right. And if you wanted to indicate this on a number line, so basically they have given this person a loan of 225,000, and then this is at period 0, right? And you get period 1, 2, 3, 4, 5. So that grace period doesn't pay anything. Okay. And then at month 4, this is what we're looking for. So we have 1, 2, 3. That is why N is 3. Okay. I hope that clears that. So now our new present value is 230,100 Rand and 56 cents. What are we calculating again? How many payments? So basically we want to know the value of N. And because we're dealing with the loan, we're going to use the present value formula. Slightly different from the future value one, where you have 1 minus this time. and then 1 plus the interest rate, and your n is negative. Okay, divided by the interest. So since we're looking for n, I'm just going to rewrite this formula. So we have present value times I divided by x minus 1 will give us negative 1 plus I to the power negative n. So let's just substitute what we know currently. So we have 230,100 Rand and 56 cents. And we're going to multiply it by the interest, which was 9% per annum compounded monthly. And we're dividing all of that by the monthly payments, which were 5,500 if I'm not mistaken. Yes. And we're going to subtract 1. And on the other end, we have negative 1 plus the interest rate to the power negative n. So let us employ the calculator. So 230,100. No, let me just use the answer before so that I don't water down the answer. So I have that multiplied by 9% over 12, and that's divided by 5,500, and then I'm going to subtract 1. Okay, so I have negative 0,686. I'm just going to leave it at that and save the answer, so I can say shift store. Where's A? A. Okay, so the value of A is that amount. What is A? Yes, that's the amount, negative 0,686. And then on the other end, if I say 1 plus 9% over 12, okay, I get negative 1,0075 to the power negative n. So I'm going to remove the negatives, and I'm going to bring this term to the left hand side. So I have 1,0075 to the power negative n is equal to 0,686. And because n is my unknown and it's an exponent, I'm going to use logs. So I'm going to say negative n is equal to log my base 1,0075 and then 0,686. So negative n is equal to, so I am going to say A multiplied by negative 1. Remember we had negative 0,686, so now I need a positive 1. Okay, then I'm going to say log 1,0075 and the answer. Okay, so I have negative 50,39. So basically n is equal to 50,39. Whenever we calculate n, we don't want to work with fractions. We're going to just round it up. Okay, so n is basically equal to 50 months. So what was the question? How many payments will Lisiba? I wrote 50 months. How many payments will Lisiba make to settle the loan? He will make 50 payments. And that concludes question 7. Question 8. We're getting closer to the end. Thank you for sticking with me. Now, determine the first derivative of the function of f of x from first principles. Guys, this question they always ask, so just make sure that you know how to do it. These are free marks, literally. So, when you use first principles, you're going to write the limit as h tends to 0, and that is something that you should never leave out. So we have f x plus h minus f of x, and that's divided by h, so that's the formula. So the limit as h tends to 0, so wherever I have x, I'm going to put x plus h. So I have 1 over x plus h minus 1 over x, and that's divided by h. So what am I going to do now? This is where I deal with fractions. Some of you do not like fractions. So basically, if I have 1 over a plus 1 over b, I'm going to multiply the denominators and then cross multiply. Okay, whenever I deal with fractions, adding or subtracting them. So I'm basically going to have x plus h multiplied by x in the denominator, and then I'm going to multiply 1 and x, which is just x, and then I'm going to have that. Okay, and then remember we have our ultimate denominator there, which is h. So I need to just simplify that, remove brackets and so forth. So then I have x minus h. Okay, when I remove the brackets, and at the bottom I have x squared plus hx, and then all of that is divided by h. So x and x will cancel, so I'm left with minus h over x squared plus hx, and all of that is divided by h. Alright, what I can do, I can simply say it's multiplied by 1 over h. Alright, and what I wanted to achieve by doing that, because I don't like fraction over a fraction, so then I can cancel out the h's. So I have the limit as h tends to 0. I'm left with negative 1 over x squared plus hx. Now I can substitute 0 in the place of h. Alright, so this term ultimately falls off. And then my final answer, whenever you write your final answer, do not write the limit as h tends to 0. Okay, we are done with that now. So our final answer is negative 1 over x squared. Okay, what I normally do, I like checking it by using the power rule. So remember they said y, okay, f of x is equal to 1 over x. 1 over x can be written as x to the power negative 1. If I get the derivative using the power rule, I'm going to say negative 1 times 1 is just negative 1. And then x, I'm going to subtract 1 there, so I have negative 2. And if I write it like this, I get the same answer. Okay, so I'm confident then in my answer ultimately. Now 8.2.1, so now we need to determine the derivative. Okay, so dx of root 4 times x to the power 6 plus root 2 times x squared. I'm going to simplify this. So root 4 is 2, and root x to the power 6, remember, if you have, they don't put a 2 there, okay, but that's basically what a root is. So we can say it's x to the power 6 times a half if you want to get rid of the square root. Okay, so basically what I'll be left with is x to the power 3, and then I have root 2 there by itself and x squared. So now that I have that, I can start getting the first derivative. And as I write down the answer, I'm not going to include this d over dx. Okay, so with the power rule, 2 times 3, that will be 6x, and then if I subtract 1, squared. Right, let's just remove that. And then here I have root 2, and if I bring 2 down, that will be multiplied by that. And then x, if I subtract 1, I'll be left with that. Okay, so I'm just going to say 6x squared plus 2 root 2 times x. And that will be my answer. How many marks? 3 marks. Now 8.2.2. So determine the first derivative of the function g. What is the function g? Well, it's basically 3x to the power 4 minus 4x squared plus 6, and then over x squared. So whenever we're looking for the first derivative, you do not want fractions. Okay, you want to put everything in a straight line without a fraction. So what we're going to do here, we're going to simplify. All right, I'm going to say 3 x to the power 4 over x squared minus 4 x squared over x squared plus 6 over x squared. Remember, if you have the same base, if I have 1 over a plus 3 over a plus 7 over a, I have the same denominator. I can just add the numerators. Okay, same thing that we're doing here. We can just simply take it step by step. Okay, yeah, that's just the beauty of fractions. So that is what we did there. And then now we can simplify it further. And I have 3x to the power 4 divided by x squared. What you'll be left with is 3x squared. Here you'll be left with 4 minus 4. And then I don't want a fraction, so I'm going to bring this x squared to the top. So that will be 6 times x to the power negative 2. Now it's at a point where I can then get the first derivative. There is no fraction because at this stage you do not know how to differentiate fractions. That's like first year work if you are going to continue with maths. Okay, that's calculus stuff. So in order to get the derivative using the power rule, 3 times 2, that is 6, and we're left with 1 there by x to the power 1. And then we have a constant here. The constant derivative of a constant is 0, so we're not going to put it there. And then here we have negative 2 times 6, which is negative 12 to the power. So we have x to the power minus 2 minus 1, that is minus 3. Okay, so if you wanted to, you could write it also like this. It's not really necessary. You could have left it, whether it's this or that, it doesn't really matter. Okay, and that's 8.22. Now let's get to 8.3. So now it says the equation of the tangent to f of x is a parabola. I see that it's a happy face parabola. So that is just f of x. So now the equation of the tangent at x is equal to 1 is given by y is equal to 9x minus 9. So the gradient is positive. So the tangent can't be this side, okay, because that's a negative gradient. So the tangent will be somewhere here. Let's just say it's there for argument's sake. So at that point, x is equal to 1. Okay, I don't know what the y value is. I don't know if I need it. All right, and we have that formula of the tangent line. So y is equal to 9x minus 9. Okay, the gradient there is 9 of this tangent. Okay, and yeah, what else do we know? Nothing at this point. That's a summary. Now it says determine the values of b and c. Okay, so this is where you apply now the first derivative. What is the first derivative? Actually, when you're getting the first derivative, you're getting the gradient of a function. Okay, so basically, we know that f of x is 3x squared plus bx plus c. So if I get the first derivative, that is equal to the gradient, and we know that the gradient is 9. Okay, so it's equal to 9, the gradient. And what is that first derivative? Basically, I'm going to use the power rule. So 3 times 2, that is 6x, and then 2 minus 1, that's 1. And then I have b, okay, because constant, that's 0. So 6x plus b is actually 9. So I can then get the value of b. Why? I can substitute the value of 1 there, okay, because they gave it to us. The equation of the tangent at x is equal to 1 is given by that. So this is where you substitute the value of 1. And then you get 9. So basically b is 9 minus 6. B is 3. Now how do we get c? Well, basically, at the tangent, the two graphs are equal. Okay, and what is the... So basically f of x is equal to the equation of the tangent. And what is f of x? F of x is 3x squared plus 3x, because now we have b, plus c. And then what is the equation of the tangent? It's basically 9x minus 9. And we have the value of the x, okay, which is 1. So we can put 1 already there. Okay. And then I wonder what that sound is. So basically we have 3. Sounds like an airplane. So we have 3 plus 3 plus c, and we have 9 minus 9, which is just 0. Okay, so we have 6 plus c is equal to 0, and c is basically equal to negative 6. Okay, so we found the values of b and c. Then we can write down, they didn't ask for this, but this is, just for interest's sake. We have 3x squared plus 3x minus 6. That is our function. And with that, we are done with question 8. Question 9, which is sort of like a continuation of question 8. It says the graph of f of x is given and it's drawn below. So we have the points E and G, which are the x-intercepts of f. Okay, great. Now 9.1, show that the values of a, b, and c are that. So they've given us the equation of f of x, which is equal to ax cubed plus bx squared plus cx minus 5. Okay, they've given us the y-intercept. And they've given us all the intercepts. If you need to look for the equation of a function and they've given you all the intercepts, basically you're going to use y is equal to a x minus x1, x minus x2, because it's a cubic function, x minus x3. Okay, that's what you're going to use. And here at this graph, you can see that it ends up being a happy phase parabola. Not a happy phase parabola, but a happy phase cubic function. And because it's happy at the end, I'm expecting that a is going to be bigger than 0. Okay. For those of you who are like, what? Basically what I'm saying is, at the end, it's happy. If it's happy at the end, then we know that a is bigger than 0. Okay. Now let us work it out. So I have y is equal to a. So x minus 1 will be x plus 1. Okay, and because we have a turning point over here, if you have a turning point on the x-axis, it means you have 2 of them, x plus 1, x plus 1, all right? And then you have another point there, x minus 5, all right? Now that we have substituted the x-intercepts, we're now going to substitute the y-intercept, which is minus 5. So minus 5, and where you have a y-intercept, it means x is 0. Okay. All right, now our only unknown here is a. So we have minus 5 is equal to a. 1 times 1 is 1 times negative 5 is negative 5. So basically a is equal to 1. Great. Now that we have a, we are then going to just substitute it in. So we have f of x is equal to x plus 1 times x plus 1 and x minus 5, because the 1 is just there. We don't really need to write it down. And then we're just going to multiply everything out. Okay, so let me start with this first. So I have x squared plus 2x plus 1. Multiply that by x minus 5. And if I continue to multiply it in, I'm going to have x cubed minus 5x squared. Then I'm going to have plus 2x squared plus x, and then plus x minus 5. Okay, so I have x cubed minus 5 plus 2 is minus 3, and then x plus x, that's just 2 x. I did something wrong here. I'm not supposed to get 2x. Okay, let's go through it again. I must get minus 9. So what did I do? Okay. Let's see. So this is x cubed minus 5x squared, right? And then we have 2x squared minus 10x minus 10x. Okay, then we have x minus 5. Okay, cool. So minus 10x plus x, that's minus 9x, and then minus 5. All right, so therefore I see that a is 1, b is minus 3, and c is negative 9. Okay, it's a good thing they told us what these values are, or else I would have made a mistake and continued with it, which is not good. All right, so that's 9.1, and then 9.2, calculate the value of x for which the function f has the local minimum value. So basically, I want to calculate this value over there, all right? And in order to calculate the turning point, I'm going to have to get the first derivative and make that first derivative equal to 0, because there the gradient is 0. So just a reminder, f of x is x cubed minus 3x squared minus 9x minus 5, and then the first derivative is 3x squared minus 6x minus 9, and I'm going to make that equal to 0. I'm going to divide by 3 throughout, so I have x squared minus 2x minus 3. Then I can factorize. Okay, so I have 1 and I have 3. Minus 3 plus 1 gives me minus 2. Therefore, x is equal to negative 1, or x is equal to 3. So what do they want? They want the value of x for which f has a local minimum. That will be x is equal to 3. Okay, so this value over here is 3 and a y value. And there we have minus 1 and 0. All right. That's 9.2. Now 9.3 says use the graph to determine the values of x for which the second derivative times x times f of x is bigger than 0. So how will that graph look? Okay, currently, if I were to draw my graph there, currently we have something like this. Okay, I can take it up. All right, if I were to take down my turning points, because this is a happy face cubic function, this is f, right? The first derivative, I'm going to get a happy face parabola. Okay, and then if I continue, no. So somewhere here, actually, my point of inflection, that is where my turning point is. And if I continue to take these down, my second derivative, I'm going to get a graph like that. Okay, So that is my second derivative graph. Now if that point there is -1 and that point there is 5, the turning point, so I'm going to get -1, 0, 1. No. What's the midpoint going to be? Oh, shucks. Sorry, I put 5 there. I'm supposed to put 3. Okay, because that's the second turning point. So that's 3. So if I have -1, then I have 0, then I have 1, then I have 2, then 3. So this point over here, my point of inflection is at x is equal to 1. So this point here is 1. Okay, 1 and 0. So here I'm going to get 1. So basically at 1, that's the x-intercept of the second derivative. So if I take my second derivative and I multiply it by the original function, I must get a positive answer. Okay, so basically how do I get a positive answer? If I have positive times positive, I get 0. If I have negative times negative, what am I saying? Positive times positive will give me a positive. Negative times negative will give me a positive. Okay, so that's what I'm looking for. Now if let me just use a different colored pen. If I look here, the values before 1, actually all these values here are negative. And if you look at your function, the original function, I also have negative values over here. Negative until I get to 0. Right? Yeah, here y is equal to 0 at x is equal to -1. And then I also have negative values until I get to 1. Okay, so what does that tell me? My first set of answers, it's basically where x is smaller than -1. That's my first answer. Negative times negative, I'm going to get positive values. So that's my first one. And then I can't use -1 because there it's 0. And they didn't say smaller and equal to 0. They just said, they didn't say bigger and equal to 0. They just said bigger than 0. Okay, so I can't include x is equal to -1. So my first answer is x is smaller than 1. Then x has to be in between -1 and 1. Okay, that's my second answer over there. All right, because like I said, we cannot include -1, so we have to exclude it. Now I'm done with the negative side. Now let's go to the positive side. So I see after 1 that my second derivative is positive. Now this one is still negative over here, so this is negative, so I can't include that, but I can only include it after 5. Okay, remember that x-intercept is 5. So after 5, x is bigger than 5. That's where I now have a positive and a positive. Okay, so those are my answers if I were to write it. So use the graph to determine the values of x. I would have said firstly, number 1, x is smaller than -1. Then x is in between -1 and 1. And then x is bigger than 5. Okay, that is how you'd use the graph. Simply put, you could have just drawn your graph over here and said this is your function. Okay, and you would have said that is 1. And then you would have seen, okay, fine. These two, negative and negative until I reach -1. And then again, I have negative and negative until I reach 1. Okay, so x is smaller than -1. X then is in between -1 and 1. And then positive the this is only positive here. So positive and positive after 5. So x is bigger than 5. Okay, that's how you use the graph. All right, and then the last question, 9.4. I hope I didn't confuse you with the previous one, but that's how I would use the graphs to determine it. So now it says, for which values of t will the graph p of x, so we have the function now, p, which is equal to f of x plus t, has 2 distinct positive roots and 1 negative root. Okay, so basically, I have my function over here. Okay, so currently, ooh, no, that's not what I wanted to draw. Okay, so that is my function. Currently, I have 1 negative root and 1 positive root. Okay, that negative root there is -1, positive root there is 5. If I take this function, oh, by the way, this intercept here is -5. Okay, and I think it's worthwhile to actually determine this point here. So I know the x value, we calculated it, it's 3, right? The x value is 3. So what would the y value be? So if the x value is 3, the y value, you just take the equation of the line, equation of the cubic function. So I have 3 cubed. I have, yes, 3 cubed minus 3 times 3 squared minus 9 times 3 minus 5. Okay, so the y value is -32. Okay, so if I take this function and I take it 5 units up, do you see? So plus 5 units, I will then have a -0 and a positive. That's not what they asked for. They asked for 2 distinct positive roots. So if I continue to take it up, let's say we take it up, okay, I'm trying to select this graph. It doesn't want to be selected. Come on now. Oh gosh. Okay. Okay. Yes, now I can select it. So I said if I take it 5 units up, I'll have a negative, a 0, and a positive. If I take it beyond that, do you see I start having 2 positives? Okay. And if I ultimately reach the turning point, then I have 1 negative and 1 positive. And if I take it up, then I just have 1 negative. So basically, if we're at this point here, like I said, we have a negative, a positive, and a positive, and that's where we want to be. Okay, but if you continue taking this graph up, like I showed you, now it's going to be at a point where it starts having 1 positive and 1 negative. Okay, so it's over a region. Okay, so what I wanted to show you here is t has to be bigger than 5. All right, firstly, because when t is equal to 5, we have a positive, we have a 0, and we have a negative. When t is bigger than 5, we have a, let me do it this way rather. When t is equal to 5, I showed you we have a negative, we have 0, we have a positive. When t is bigger than 5, we had a negative, a positive, and a positive. But this value here, -32, once it reaches 32 units, once we take it 32 units up, when t is equal to 32, we had a negative, and then a positive. This is what we have. Okay, we have a positive and we have a negative. Okay, but if t is actually smaller than 32, we have a negative, a positive, and a positive. Okay, this is when t has gone up 32 units. This is t just below 32 units. So you see it has two positives and one negative. If t goes beyond 32, we now have only a negative. Okay, so I hope you understand what I'm doing over here. So ultimately, what does t need to be? T then has to be bigger than 5. Okay, and t has to be smaller than 32. So t has to be in between 5 and 32. And that's how you're going to get your answer. Okay, and that is it for question 9. Question 10. This is the second last question. So EHGF is a rectangle. Okay, we can see it. HE is produced x squared centimeters to n, and EH is produced x squared centimeters to p. NF produce intersects PG produced at M. Whew, so many productions here. Okay, to form an isosceles triangle MNP with NM is equal to MP. D lies on NP where MD is perpendicular to NP. NP is 4 centimeters and MD is 3 centimeters. Okay, I hope you followed through with that information given. So now it says show that the area of EFGH is given by that. Whew, okay, a lot was given. Firstly, let me see if I can get the length of EH. Okay. Yeah, I think let us start there. All right, because I have NP, I'm just going to put it here. I have NP as 4 units. Or is it 4 centimeters? Yeah, 4 centimeters. That is the length of NP. And then, okay, so halfway there we have D, and then we have EH. Okay, and I'm also told that EN or HP is actually x squared. All right, so if I need ED, I know that ND is actually 2 centimeters. All right, so ED, which is equal to DH, will be equal to 2 minus x squared. All right, so now because EH is equal to 2 times ED, all right, I have that EH is 4 minus 2 x squared. Okay, are we good with that? Yeah, let me just indicate it there on the drawing so that we know what we are working with. Okay, let me just make it a bit bigger. So, as I said, okay, EH is 4 minus 2x squared. Now, how can I get GH or FE? Okay, so FE, which is equal to GH, because we're dealing with a rectangle, that is equal to B. Okay, but now, how am I going to get this B? Okay, let's see. So what I can do, let's use a different colored pen. I know that D or ND or DP, that's equal to 2, right? Let me just actually draw it this side. So if I were to look at this big triangle, M, N, and D. I know that ND is 2 centimeters. And I know that MD is 3, they told me. Alrighty, now how can I get B? So B is here, right? I have F, E, N, and I know that En is x squared. Okay, now they told me already that MD is perpendicular to NP, so I have a right angle triangle. And then also, because I have a rectangle, remember the properties of a rectangle, so you'll have that FE is parallel to GH, FG is parallel to EH, and so I'm expecting as well that MD, since it cuts this big triangle in half, that's actually also a bisector, okay, and it's actually parallel to FE as well. So with that being said, I can then use FEN and say that FE is actually perpendicular to NE. And I hope you've realized, but that then would mean that triangle MND is actually similar to triangle FNE. That's the assumption. But let's see. Is F equal, okay, there's F. Would F then be equal to M? Yes, it would. Okay, because we have, like we said, MD is parallel to FE. So the angle over here is equal to the angle over there. All right, corresponding angles. And then is D, okay, let me just see again, is N equal to N? Yes. Those are the common angles. And then D, or rather let me say F and E. So E is equal to D, okay, which is equal to 90 degrees. All right, so yeah, we have that. So we can then conclude that the two triangles, triangle FNE is similar to triangle MND. All right, and if that's the case, we can then use proportionality. Okay, because with that, really, you just really need two sides that are parallel. Okay, so yeah, let's go ahead, and if that's the case, we can say then Fn over Mn is equal to Ne over Nd, which is equal to Fe over Md. So what do we have? We have Md, yes. We have Nd, F is what we're looking for, which is B, and NE we have. Okay, so we're going to use those last four. So NE, we know that it's x squared. ND is 2. FE is B, and MD is 3. So then if I'm solving for B, B will be equal to 3x squared over 2. Okay, now we can finally get the area. So therefore, the area of rectangle EFGH will be equal to B, which is FE. Okay, so B times EH. Okay, and we found that B is 3x squared over 2, and that EH is 4 minus 2 squared, 2x squared. So then we can say 4 multiplied by 3 over 2. That's going to be 4 divided by 2 is 2. 2 times 3 is 6. So I have 6x squared. And then the 2's will cancel. Then I'm left with minus 3x to the power 4. And that is what we have shown. The nice thing about these types of questions is you know what you're working towards, so it makes it a little bit easy, and you know as well if you are wrong. Okay, now it says calculate the maximum area of rectangle EFGH. If you couldn't prove this area, do not lose heart. You can continue with this answer because it has been given. So if our area here is 6x squared minus 3x to the power 4, if you want to get the maximum or the minimum, you need to get the first derivative. Okay, and then make it equal to 0 and then solve for x. So I have here 2 times 6, which is 12x, and I have 3 times 4, which is 12x. 4 minus 1 is 3. I'm going to make that equal to 0. Then I'm going to take out the common factor here, which is 12x. Then I'm left with 1 minus x squared. Okay, difference of two squares. So I have that 12x is equal to 0, or 1 minus x squared is equal to 0. So I have x there being equal to 0. And I cannot use that because if I use it, then I'm not going to get the maximum area. I'm going to get the minimum area. So we're not dealing with that. But here, x squared is equal to 1. And what I can do, I can actually write it like this. X minus 1, x plus 1. If I take out a negative, okay, just in case you're wondering how did I even get there. I take out a negative, that's what I get. So basically, x is equal to plus or minus 1 in this regard. Now, if I want to calculate the maximum area, I will substitute 1 in there. Even if you substitute negative 1, it doesn't matter because you have x squared and x to the power 4. It will become positive either way. So there we go. And then I have 6 minus 3. So basically the area that I have is 3 centimeters squared. Alright, and that is it for question 10. And we have finally reached the end of the paper. Question 11. Again, please do not forget to like our videos and subscribe to our channel. And please tell us where to improve because we are here to serve you and have maths easily understood. Okay, so 11.1, two events A and B are such that probability of A is 4. I don't know why I'm rewriting this because it's there. And then probability of A or B. Okay, A or B is actually equal to 0.52, and A and B are mutually exclusive. So if I had A over there and I have event B, this is what it means. There is no intersection. So probability of A and B is actually 0. Okay, so these are mutually exclusive. Now it says calculate the probability of B. So the equation I'm going to use, probability of A or B is actually equal to the probability of A plus the probability of B. We have the probability of A or B, which is 0.52. Probability of A is 4. 0.4. I was like, what? How are we having 4? We're not supposed to have a probability that is higher than 1. Okay, and then we have probability of B. Now, if I'm going to calculate the probability of B, that's simply going to be 0.52 minus 0.4, which is just 0.12. And that's it. I think it's probably going to be 2 marks or something. Yeah. Alright, then we get to the Venn diagram. Okay, so let's see. The items that a learner bought at a tuck shop were recorded over a period of time. The probabilities of the learner buying a sandwich, a chocolate, and a juice are shown in the Venn diagram below. That is a wonderful combination, by the way. Okay, you gotta have a bit of chocolate there. Okay, so first question, 11.2.1. What is the probability that a learner will buy a sandwich? Okay, so if the learner is going to buy a sandwich, so probability, I'm just going to say PS. Probability, oh, there's another chocolate, PS. Probability of buying a sandwich, you're basically going to add, let me just make this visible. This is a sandwich, okay? So you're gonna go and highlight your sandwich over there and just add everything up. Okay, so basically we're gonna have 0,01 plus 0,02 plus 0,09 plus 0,04. Okay, put them all in a calculator. Plus 0,02 plus 0,09 plus 0,04, and then you get that your probability is 0,16. Okay, let me just get rid of that. And then, okay, 11,2,2. Calculate the probability that the learner will buy at least 2 of the 3 items. Okay, so if they're going to calculate or buy at least 2 items, it means that at most they can buy all the items. Okay, so they can either buy chocolate and a sandwich, or they can buy a sandwich and a juice, or they could buy chocolate and the juice. My son would love that a lot. Or they can buy all of them. Okay, let me just undo that because now I'm hiding the numbers. Alright, so that is what it means. If they say at least, then you should consider what most, the situation of having the most. And when we calculate these, we're basically going to calculate the intersections of those two and all of them. So everything that I've highlighted, that's what we're going to add up. So I have 0,01 plus 0,02. Basically writing it in order. 0,04. Okay, so that is 1 plus 2, which is 3 plus 3, that is 6 plus 4, that is 10. So 0,1. Okay, nice 2 marks. And then 11.2.3, calculate the probability that the learner would not buy any of the 3 items. So basically, after adding everything up, like literally, okay, there's something that's not included. That's what we need to calculate. So I'm going to say 1 minus, okay, the probability, what is it? Calculate the probability that a learner would not buy any, okay, let me just write this down. So probability of not buying anything because you're just not in the mood. We're going to say 1 minus, and we're going to add everything up inside. I already know that the intersections are equal to 0,1. So I'm going to add the remainders. So I have 0,04 plus 0,2 plus 0,09. Okay, I'm just going to put all of that in the calculator. 1 minus 0,1 minus 0,04 minus 0,2 minus 0,09. So I get 0,57. Okay, so we're done with question 11.2. We're not yet done with the paper. Don't get too excited yet. We're almost there. So 11.3. 7 guitar players, each with a different name, participate in a concert. Alright. Now, in how many different ways can the names of the guitar players be listed, one below the other in the program? Okay, so you have 7 of them. Alright, if in the first position you have 7 possibilities, once you have used up that one, you have 6 possibilities, and then 5, and blah blah blah. So basically, this is 7 factorial. So what is 7 factorial? It's 5040. And then 11.3.2. After the performance, the guitar players wait backstage. There is a bench with only room for 4 of them to sit on. Okay, so what must happen to the other 3? Now, what would be the probability that the 4 guitar players will be sitting in alphabetical order from left to right. Okay, so for example, I'm just going to say, what if the first person has A? The name starts with A, the other one starts with B, C, D, E, F, G. Okay, and now they're sitting in alphabetical order. So A, B, C, D. Okay, so what is the probability that they'll be sitting in alphabetical order? Okay, so because they have different names, they didn't say there's one that has the same name, or maybe the letters are the same. The first letter of each name are the same for certain players. All right, so actually, in the 4 seats, there can only be one A, and there can only be one B. There can only be one C and only one D. Okay, that's what I'm getting at here. So the probability then, and then what we need to look at, what are the total number of possibilities that one could have here? So you have 4 out of, before I get to the probability, you have 4 out of 7, right? So what you're going to put there, on your calculator, okay, let me just do this. So you could say we have 7 factorial over, so 7 minus 4 factorial, okay? Or you could use this function of the calculator. It's called NPR, the N being 7. Then you have P, and then the R is 4. Okay, so you can work that out. Or you could say of the 4 spaces, okay, you had 7 initially, then 6, then 5, then 4. Okay, all of them should give you the same answer, but let's just check. So you have 7 factorial, and then 7 minus 4, and then there's the factorial again, which I have lost. Okay, there it is. So it's 840. Okay, the NPR, if you say shift here, do you see on the multiplication sign? If you look at the yellow, you see the NPR. So if I have 7 P4, you're also going to get 840. I just wanted to show you that you're going to get the same answer pretty much. Or if you say 7 times 6 times 5 times 4, you're going to get 840. Okay, so those are the possible options that you have. All right, so if we get the probability of that whole condition, basically you have 1 times 1 times 1 times 1. So 1 over 840. Okay, and that probability, I think you can leave it like that. 0,0012. Okay, yeah, so you can do that. When I first looked at this question, I was tempted to say the probability of will be equal to that NPR, which is 840, over the entire possibility there, 5040. Okay, which would give you 1 over 6. Okay, but see, the trick is when they say each player has a different name and they want the players to be sitting in alphabetical order, I don't have 7 options of A. I only have 1. I don't have 7 or 6 options of B. I only have 1. So that's where, yeah, it becomes a little bit hoo-hoo. But please just comment below, how would you approach this question? All right, and then lastly, 11.3.3. During the performance, the 7 guitar players sit in a line on stage. Okay, so 7 of them. We haven't excluded others. All right, 4 guitar players are female and 3 are male. All right, in how many different ways can they be seated if the males may not sit next to each other? So if the males may not sit next to each other, you can have female, a male, female, male, female, male, female. Or you could have a male, female, male, female, male, female, female. I mean, there are some ways of doing it, but you just need to make sure the males are not sitting next to each other. How I normally approach these questions, I would rather look at what happens if you have the males sitting next to each other. Okay, so you have the males sitting next to each other, and then you have the females there. However way you would put it, I mean, the males could also sit here or sit there, you know. Yeah. So what would happen if the males would sit next to each other? And I would get the possibilities of that. And after getting the possibilities of that, I take the complete possibilities that are there offered, and I subtract the possibilities of males sitting. So basically getting the inverse, or not the inverse, the complement. Okay, if it's not 0.3, it's going to be 0.7 type of vibe. Complementary. Okay, so males sitting together. So I need to go work out the possibilities of the males sitting next to each other. So in this scenario, I have all these males sitting next to each other. Next together, wow. Next to each other, they're sitting together. So I take that as 1. Okay, and then I have 2, 3, 4, 5. Okay, so then I have 5 factorial. So males sitting next to each other, 5 factorial multiplied by this inside here. The males can also sit anyhow. So it's going to be multiplied by 3 factorial. And when we work that out, so we have 7 factorial minus 5 factorial times 3 factorial. Okay, and we get an answer of 4,320. Let me just read the question. Did they ask for probability? No. They asked how many different ways they can be seated. So those are the different ways. So I didn't take this approach because there are so many things that I would probably not, I wouldn't have considered. But if I then choose to do the complement of the scenario, then it works out better for me and I understand it much better. And with that being said, that's it for Maths Paper 1. We'll post Maths Paper 2 in a few days or a week, depending on how hectic my schedule is. But thank you for tuning in, and I hope you've learned quite a lot. Again, don't forget to like our videos and subscribe to our channel.